Well, here's another related rate example. A spotlight is on the ground 20 feet away from a wall, and a 6-foot tall person is walking towards the wall at a rate of 2.5 feet per second. How fast is the height of the shadow changing when the person is 8 feet from the wall? Let's draw the picture here and see what we can figure out. So here's the spotlight. It's on the ground, and it's 20 feet from the wall. That's not changing. We're not moving the spotlight. A person, 6 foot tall, and again, that's not changing. They're 6 foot tall, is walking towards the wall at 2.5 feet per second. And this thing is beaming up a shadow onto the wall, like that. So we want to know how this length is changing as they are walking. Okay, so we know this, I guess, rate as well. Now, let me maybe do a little bit of naming here. Let me start by just saying that red piece is x. Okay. Now, the shadow problems like this, the equations are typically similar triangles, and we'll see if that works out. Let's write down the rate that we know. We know dx dt is 2.5 feet per second. We know how fast the person is walking. What we want to know is how their shadow is changing, how that y is changing. Okay? The equation, well, again, I think that our best bet here is to do some similar triangles, to focus on this little triangle and compare it to the big triangle. Okay? So let's do that. Let's start with the big. The height is to the base, and they're in a similar relationship to the other, where the height is to the base. Now, to get the base, we could say that that's just, I suppose we could say that's just x. Okay? So what might be nice here is, multiplying both sides by 20. So you maybe had like y equals 120 over x, something like that. Or maybe, since we know we're going to need the derivative, we'd like to write it as y equals 120 x to the negative first. All right, so derivative. Well, dy dt is equal to negative 120 x to the negative second dx dt. Maybe it'd be easier to write it as negative 120 over x squared dx dt, like that. Okay. Now, to substitute and solve into this, well, we are looking for dy dt. We know that x is 12, because I've set x up to be the person's distance from the light. This person's 8 feet from the wall, so x would be 12, right? 20 minus the 8. So we'd have negative 120 over 12 squared multiplied by 2.5. Okay, if we type that in, now if you type all this in, you get negative 25 twelfths. And it would be feet per second. Now, I just want to explain this real quick, because that's our rate of change. So it says, now, is the shadow increasing or decreasing? Well, it must be decreasing. Our rate is negative. I'm just going to put rate is less than 0. This doesn't really make sense to people, but I want you to think about it. If you start, here's a spotlight, and you're standing right here, that light creates a huge shadow. Then all of a sudden, if you're over here, that shadow projects like that. So as you get further and further from the light, the shadow will actually shrink down. So that negative should make sense.